Okay, so quick check, guys. Hello, everyone. Good afternoon. So are we live? I think, can you guys confirm? Hello, hello. Yeah, I think we are live. Hello, guys. Good afternoon once again. Hello, how are you guys doing? Okay, so welcome to the GATE Academy session on previous year's question of IIT Kharagpur network theory, guys. So network theory is the topic we are going to, is the subject we are going to get started. And the reason for looking at the previous year's question from IIT Kharagpur is that I think all of you guys must be aware that IIT Kharagpur is going to be the organizing committee or the organizing institute for the this year GATE 2022. So that is the whole intention, and to highlight this, that okay, what kind of question they ask in network theory, what is the general trend in terms of difficulty, is network theory still very scoring? So we're going to answer those questions, and we'll also take some good question from the previous year's IIT Kharagpur. So I think we have Ankit, Zubair. Good afternoon, guys. Loud and clear. So this is for EC electrical ion. So this session is for EC electrical ion, Zubair, not for mechanical guys. Hi, Pavitra. Hi. How are you guys doing? So colleges are again open, or you guys are doing still online classes, working from home like everybody is doing these days? How are you guys doing? Let's be a little responsive in the chat before we start. Hi Ashish. Hello, hello. So for our friends who joined maybe maybe a little late by 1 minute or 2 minutes, okay. So let me recap. So IIT Kharagpur is going to be organizing institute for GATE 2022, and that's the reason we are starting with network theory session, where we are going to look at some of the good question being asked in network theory subject, guys. Okay. So we are going to use another 30 minutes for this, and be ready for it. But before I do that, let me introduce myself. My name is Akash Pushkar, and I'm an IIT Kanpur alumnus. So did my master's from IIT Kanpur, did BTech in electronics from Roorkee, and currently I'm working as a subject matter expert for network theory, guys. So that's all. And if I ask me about teaching experience, so more or less, I would say more than a decade now. So without wasting any further minute, let me start with the very first question, guys. So can you guys see the question on the screen? This was asking GATE 2014. GATE 2014, guys. Anybody wants to answer this question? I'll give a minute. So it is a very, I'm starting the session with a very easy question, my dear friends. It was asking GATE 2014. What is the answer? Come on. I need the momentum here. I need the energy. Norton's theorem states that a complex network connected to a load can be replaced with an equivalent impedance. Options: in series with a current source, in parallel with a voltage source, in series with a voltage source, in parallel with a current source. What do you guys think? So I'm seeing the responses from Ankit, Ashish, option D. Okay. Ravi Teja, option D. So I think most of the guys are saying option D. Most of the guys are saying option D. So let me give you a little background on the Norton's theorem. See, I'm not here only to just give you the answer key, right? So Norton's theorem, or Thevenin's theorem in original, why do we need Thevenin's theorem or Norton's theorem? The main purpose of Thevenin's theorem or Norton's theorem is to represent a big complicated linear network with a small block where we have a voltage source or current source. We call it as VTH or IN, Norton's current source, connected with a Thevenin's resistance in series in Thevenin's, right? Or connected with a parallel resistance in Norton's equivalent. So since this question is related to Norton, right, and it simplifies your complicated networks, let me quickly draw the the representation, my dear friends, mind my words, it has to be a linear two-terminal network. That is the requirement for this theorem to work. So it's a linear two-terminal network, and you can replace any network with this box. And in this, guys, you are connecting, right? You are connecting, you are having a load resistance, right? So any big network you're representing with this block, this is a varying, load resistance IL, and the current in this is IL. IL is load current. And if you equivalently want to represent, right, with a Norton's equivalent, so how will it look like, guys? It will look like a Norton's current source, which is IN, right? In parallel, you have a Norton's resistance. Generally, Rn is always equal to Rth. So what we have done, guys, let me highlight this block. What you have done, actually, I'm using highlighter. You have represented this block with this block, guys. Come on, yes or no? We have represented this blue block, linear two-terminal network, with a simplified block where you just see a Norton's current source with a Norton's resistance in parallel, right? It has simplified this network. Inside this blue block, this side, it might have a lot of sources, independent voltage source, current source, a lot of resistances, but we are not bothered about it. We are just saying that I will put one current source, one source equivalent of everything there, right? That is the beauty of Norton's. And then you will connect back your load. So this is again your RL. Now, guys, clear? So tell me, if I have to find this load current, open question to the forum. See, this question will solve, don't worry, but I'm giving you a background. So this question will solve, but in the background, if I may ask you, what is this load current? What we will do? Come on, guys, come on, quickly. We don't have that much time. Maintain the energy. What is IL? Come on. Can you quickly find IL? You can do that, no? So see, you have a Norton's current here. This is IN, right? And then the current is getting divided. So what is IL? Apply current division rule. IL will be equal to 1. The resistance which you will take Norton's one. So you will take this resistance divided by, right? Divided by total, which is Rn plus RL, into the source current. Source is what? Norton's current. Is this right, my dear friend? Come on. Yes, no, guys? Quickly. Very good, Ankit. Ankit, Kishan, very good, guys. You are right. Now, coming to this question is super simple. These are like lollipop, asked in GATE 2014. The answer is what, guys? Answer is option D. Very good. So I think most of you guys have got it. Let's move to the next question, guys. Come on. This is another question that they asked from the topic, I would say resonance, a little bit of theorem. Norton's theorem is again being asked here. Can you guys see that? Right? So, or obviously you can also put it in AC circuits, because given that resonance happen in AC circuits, right? What is the answer for this question, guys? Can you see on the screen? Let me manage the space here a bit. So I'll just push it down. Yep. So take a minute or so, guys. In the meantime, I'll give you this question background. So they're asking, looking at this circuit at which the Norton equivalent impedance as seen from the terminals B dash BB dash is purely resistive. So looking here, they are saying what should be the value of omega? What should be the value of omega so that the overall Norton's impedance is what? Purely resistive. Good question, na? And it's a numerical answer type question. What is the type of question? Numerical answer type question. These are the concepts you might need to use. Look at that. Again, waiting for your answer, guys. Come on. I hope somebody is solving it. This was also asked in GATE 2014. GATE 2014. Ankit, Kishan, my eyes on you guys. Since you have answered the last question very beautifully, you did answer in, I think, 10 seconds flat. A lot of people did that, but this is another question from GATE 2014. What do you guys think? What should be the answer? Come on. And since it's a numerical answer type question, you cannot afford to make a mistake. Hello guys, come on, come on, come on, come on. This is a very beautiful question. Given GATE is going to happen in another 5 months, I expect you guys to do this question. No luck? Okay, let me take. So guys, first of all, for this circuit, can you find what is going to be Norton's impedance, Zn? Can you guys do it at least? And to do that, what is the step you take? What is the step you take? You kill the sources, right? You remember, if you're supposed to find what is Zn, right? What is Zn? You will what you will do with the voltage source here, guys? Come on, guys. And this is, there is a typo I can see. This is a voltage source. What you will do? You will make it what, guys? Come on. You make it short, right? Voltage source is getting short circuited, current sources are getting open circuited, right? So if you look at here, you're going to make the voltage source short circuited. So what is the Zn you will see? You will see, let's call this as R, and let's call this as inductor. Guys, this is an inductor. Okay, this is your capacitor. So what I can write, this is an inductor, this is a capacitor. So first you convert this in your mind in the Z component. So what is ZR? ZR is R. What is ZL? Don't forget these things. What is ZL, guys? J omega L. What is ZC? 1 upon J omega C. How the connection looks like? You have a resistance in parallel with a inductor and then a capacitor, right? In series. Yes or no, guys? So how will you write this in terms of impedance? You will write R in parallel with inductor. So how will you write it? You will write R into J omega L upon R plus J omega L plus, guys, come on, plus 1 upon J omega C. Guys, are you guys there with me till here? Any doubt, any question, please let me know. Kishan, answer is not root 2. Answer is not root 2. Just to tell you, in case you're hoping that my answer is right or wrong. Guys, is it okay? This is like parallel connection, right? And then series, so I've added it. Now what you're supposed to do, you are supposed to simplify this by putting the values. So Zn is equal to R value is 1, J is J, omega we are supposed to find, inductor is, I would say, half, right? Upon 1 plus J omega by 2 plus what is 1 upon J omega C, so omega C, so J omega and capacitor is 1 farad, right? I think we are there. Guys, come on, help me out here. Okay, so what is that you get now, guys? Come on, you get Zn equal to, you get what? 0.5 J omega. Look at that simple thing here. 1 upon 0.5 J omega. Okay, plus 1 by J omega. Now you are supposed to make this overall impedance as what? Resistive. Resistive means what? If impedance has to be resistive, what is your mind say? Come on, guys. Impedance has to be resistive means what? That imaginary part has to be 0, right? So imaginary part must be 0. Come on, guys. For impedance has to be resistive, imaginary part should be equal to 0. Hello? Yes, no, guys? I'm waiting. Come on. So this is the concept. The what 2 lines I've written here, this is your concept. This is the concept you should learn. And it also happens when you do resonance circuits, right? You are more or less, you have been used to do that. Whenever a resonance question is there, you are supposed to make the imaginary part 0, because in resonance or at resonance, circuits become purely resistive. Yes or no, guys? So at resonance, circuit becomes purely resistive, means I have to somehow get the real part here and the imaginary part here. So I know a little calculation is there, but we'll do it now. So see, if I take an, see here 1 by j omega, so I can be a little smarter. So what I'll do, I will write 0.5 j omega and I'll multiply with 1 minus 0.5 j omega and divide by 1 plus 0.5. There are different ways to do it, but I think this is super fast. And this what? J, if you multiply up and down, so you'll get what? You'll get minus j by omega, guys. Come on. Okay, so I need to push it a little further and cool. So guys, what is Zn? And you have to do the maths here. So 0.5 j omega minus j square plus, so it is plus 0.25 omega. And please help me with the calculation. A plus b into a minus b in terms of a plus jb, a minus jb, so it will become a square plus b square, so it is 1, or it will become 0.25 omega square. Guys, come on. Right, guys? And anyway, this is what? Minus j by omega. So if you find the real term and imaginary term, you'll get an idea. So what are the terms here? So real term is 0.25 omega upon, and please take a look at my calculation. This is calculation intensive, so I might make a mistake, so you have to be careful. 1 by omega, and then it will become what? Minus 0.5 omega upon 1 plus 0.25 omega square. Right, guys? Cool. So guys, our job is very simple after that, and just have a quick look. So if you're trying to take 0.25 omega, right? So 1 by omega minus 1 by omega minus 0.25, 0.5 by omega. I think this is fine. So I have to make this 0, right? So to do this, what I'll do, I'll write 1 by omega equal to 0.5 omega by 1 plus 0.25 omega square. Let's see what happens. So 0.5 omega square equal to 1 plus 0.25 omega square. So ideally it is what? 0.25 omega square equal to 1. So omega square equal to what? How much? 25 by 100, 4. So I get omega equal to 2 rad per sec. Anybody who got 2 radian per second, guys? Anybody who got 2 radian per second? Who got 2 radian per second? Kishan. Okay, Kishan got finally 2 radian per second. So guys, be ready in IIT Kharagpur. When they set paper, they might give you a little calculation intensive question from the area of sinusoidal steady state analysis of AC circuit, which I can see here. Can you guys see that? So answer is what? 2 radian per second. You guys agree? This is a calculation oriented question, guys. Agreed or not? Now, what is the best strategy? So I'll also tell the strategy. When you are writing GATE exam paper and you see a question in which you know that it is going to take some time, maybe around 3 to 5 minutes of time. So don't do this question at that point of time. That is my, I would say, golden advice, guys. Because you know you can do it. You know what is the concept. I have to make it resistive, means imaginary part should be 0 of the impedance. We know that, but to do that, I know it is complex calculation, given that imaginary, real, and all, it will take some time, quite some time. I will put it this question for later. I'll not do it right away. I'll mark that I can do it. I can make this question right, but I might do it later, because your aim should be in GATE paper to look for the easy question, right? Because that will also give you 2 marks. This will also give you 2 marks. Why to waste time? Getting agreed, guys? Hello? I hope you guys agree with me on this. Kishan, Ankit, what do you guys say? Makes sense, right? Okay. So now, without wasting a single second, let's move to the next question. This is going to be very important part in GATE exam, guys. Why? Because star to delta, they ask a lot of questions these days. Almost every year they're asking question, guys. So to be very honest, if I have to be honest, guys, be ready for question like this. Okay, be ready for question like this. So please take a look at this question, guys. Come on, it's very straightforward question. It's very straightforward question. Let's see what is the answer, guys. A lot of time what happens when people are looking at star delta question, they forget the formula. Is it happening with you guys also? So whenever you look at star delta, you're always confused what to do, star or delta to star. So we always tend to forget the formula itself. So what I did in my time, I put the formula on the wall. So suppose I'm studying anywhere in my room, so I'll put these some important formula which I tend to forget on the wall, right? Study wall, where I will be keep looking when I'm roaming in the room. So that is another advice which can help you to strategize your preparation, so that those things which you tend to forget, you might be seeing every time on the wall, and that's where it will help you to retain those concepts. Okay, so guys, when already what they have given you a star or delta, they have given a y network. Can you see this y network, guys? They've given this y network and they're asking, find me what is Rn. So meaning to say, what is the conversion you're doing, guys, here? What conversion it is? Star to delta or delta to star? Hello, 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 hello. What are we doing, guys? Come on, tell me. Are we doing star to delta or delta star? You should answer this question quickly. Right? We are doing here what conversion? Star to delta. Star to delta. Okay. Sometime you should be able to identify it. Otherwise, how will you put the formula? Then you have to remember the formula, guys. So in this case, the formula is, suppose I am willing to find R1, right? So to get R1, you have to take the adjacent one, adjacent arm, and add it up. Just like suppose you are looking from this side. So these two will be like, to you, this will be in series. That is the hack I'm giving, guys. So looking from this side, this will should look to you as in series. So that's why you will add quickly these two. Then what is the next step? The next step is that then you take these two, multiply and divide by the arm which is just opposite to R1. That is the trick you have to remember. Somehow you have to remember. So if you solve this, it is super easy, guys. If you know the formula, this question is like a cakewalk. So I think answer is 10 ohms. Answer is 10 ohms. Got it? Anybody got it? Yeah, Ashish, Nikita got it, Kishan got it. Good, yeah. Okay. Okay, cool. So I think we are almost on the top of the hour. So these are the some questions, and we'll keep coming to you guys and do questions pertaining to this, right? So my 2-3 comments on the paper set by IIT Kharagpur, right? So what is my insight is on the paper from IIT Kharagpur? The first insight is that AC circuit question will be calculation. Questions would be calculation intensive, means you have to do some intense calculation. So be ready for it. So be ready for it. Second is that it's very scoring. So network theory question from IIT Kharagpur is very scoring, my dear friends. So most of the time you can maintain accuracy of 80 to 90%. You should be able to attempt 100% question and you will get easily 80-90%. Okay, so these are my 2 bullets point for the network theory IIT Kharagpur questions which I have seen over the year. And you know that generally one IIT will conduct the paper after a long period of time. So the last time they conducted in 2014, and I think before that it was long back around 2006. So it doesn't make sense. 2006 is like 15 years back. So there's no point in going so back in analyzing the paper. The 2014 paper you should guys attempt completely from EC electrical and IN branch, all the network theory questions. And please, in case you're not able to get any question, any doubt, any challenges you're facing, please comment in the chat. Okay, can you guys do it for me? Since they're putting a lot of efforts, so I would suggest guys two things to do that. Please share this video, share this session with your friends within your WhatsApp group. Also try to let the guys know that what are the trends we have discussed in the paper, so that everybody is getting benefited from this session. And if you have any question, any doubt, any concern, you can keep continuing on this thread. And to do that, I'm giving a question as homework as well. So I will be coming back and answer this question once somebody has done it. So please take this question, guys. Can you take a screenshot? This is the last, and this is a homework. This is a very good question from IIT Kharagpur paper in 2014. This is more like a homework for our communication to continue. So they have given a network, right? Two-port network, and they're asking you that what is the impedance matrix in ohm? Okay, so that is a question which you can do. So will anyone attempt, and they will answer in the comment? Will anyone will attempt and answer in the comment, guys? Come on. Ashish, Kishan, what do you guys think? So I will be coming and seeing on the comment section that did anyone really solve it? Okay. Chandan, I think you are lagging behind. That question is over, my dear friend. 10 ohm is the right answer. You are right. And this question is done. I'm talking about this question, which I'm giving as a homework from IIT Kharagpur. Okay, so that's all for the session, guys. And thank you very much for joining the session. And be watchful of this YouTube channel. I would suggest that subscribe to this so that you get any notification is coming. Subscribe and click on that bell so that if any notification is coming for the coming webinars, we are going to do a lot of webinars for you guys. Keep coming in the session, keep practicing, and get amazing insights. So that was all from my side, guys. Thank you very much. Take care.